Hi everyone. We'll get started at around 6:04 as usual. All right, we'll go ahead and get started. And so we won't need Eclipse for these next few slides, but uh just get CodingBat open if you can. I can send the link again. Uh all right. You don't need CodingBat yet, just have it prepared. All right. So uh all right, so yeah, we finished up with else if last time. So now we'll get into compound Boolean expressions. So, instead of using an if statement inside of another if statement, if you remember for many of the coding bat problems that we did, uh, I had like if statements inside of if statements, and it was longer than it needed to be. So instead of doing this, we can use something called compound Boolean expressions. So for example, with this one, instead of checking if x is greater than 2, and then checking if x is less than 5, and then printing this, we can just check if x is greater than 2, and this symbol over here, it means and. So I'll just write that in. This is and. So we're checking if x is greater than 2 and x is less than 5. And if it is, then we print this out. All right. So we saw and, but just to get into some other examples of logical operators. So yeah, there was and, as I mentioned. There's also or, which is basically two of these vertical lines. And if you do shift and you go to the very right side of your keyboard, you should see this, and that's how you'll be able to type it. And then so or basically if if the first condition is true or the second condition is true, then it'll return true. And if both of them are false, then it'll return false. But the point is for or, only one of them has to be true for it to be true. I mean, like if if you think about this, if this or this, then you're saying if this is true or this is true. But then with and, both of them have to be true because you're saying this is true and this is true. All right, and then our last one is not. This is just our exclamation mark, and basically it reverses whatever's here. So basically, um, it's saying not 4 greater than 5 over here. So, or before I get into this, so the not just it reverses it. So let's say we have like not false, it'll be reversed into true. And then if we have not true, it'll be reversed into false. All right. Um, so now let's get into these examples. So we're checking if 4 is less than 5, and so I'll just write this out, and 6 is equal to 3. So with 4 less than 5, that's true. But then 6 is equal to 3, that's false. So if we have true and false, that will become false. So ultimately, since this is not true, since this is true, but then this is not true, uh, it'll ultimately output false. Um, all right. Then 1 second. All right. So for or, so I'm just writing this out. So this middle thing is or. Uh, hang on. That's not clear. So 4 is less than 5 or 6 is equal to 3, then we want to return true. So this will be true, but then this will be false. But since it's or, we just need one of them to be true. So if this is true or this is true, then it'll return true. And since this one's true, uh it returns true ultimately. Okay. And then for the last one, remember not, it reverses whatever's here. So we have not 4 greater than 5. So 4 greater than 5, that's false, right? So we have not and then false. But then if we take the opposite, so it's not false, that'll be true. So this will return true. Uh, all right, so I'll go into all of the different cases for uh that you can run into with this. So let's say we have two numbers, sorry, or two booleans. So there's boolean A and boolean B. So first, let's check the different cases when we have A and B. Uh, yes, Liba, you have a question?
Yeah, on my coding, it doesn't have the console at the bottom.
Uh, wait, so you don't need to code right now, but uh, are you saying for what is this Eclipse or
Yeah, on I Eclipse, yeah, IDE.
okay, one second. Let me try to figure it out. Okay, go to the top of your screen. Uh, is there something like you see like over here? I have like Chrome, File, Edit, View. Is there something that says Window?
Uh, window? I
Yeah.
mean, file, edit, source, refactor, navigate. I don't know. Oh, here's window. Yeah,
Then, so when it says Window, there should be something that says Show View. If you,
yeah.
and then there should be Console if you hover over it.
Oh, yeah, it worked. Thank you.
All right, no problem. Okay, so let's go to the case for A and B. Sorry. So if A is true and B is true, so that's this first case over here. Uh, let me try. So if A is true and B is true, then it'll return true since both of them are true. Then for our second case here, so we have A is true, B is false. Uh, so that's true and false. And since both of them aren't true, then it's going to return false. So if you see over here, it returns false. Uh, just just don't worry about these other columns yet. I'll get into it. Just focus on these three. Um, so yeah. The next one, if we have A being false, B being true, so we have false and true, then it's going to return false since both of them aren't true. And then for our final case with this, uh, we have A is false. We have A is false and B is false. So if A is false and B is false, then so neither of them are true, so it's obviously it's going to return false. All right. Now for our second one. So for this, don't focus on this. We already did it. Don't focus on these either. Just these three columns. So we have A or B. All right, so if A is true or so it's this one, A is true, and then B is true. So we're saying A is true or B is true, then it's going to return this one's going to return true since both of them are true. Um for our uh for our second case, so we have A or B. So remember, or means only one of them has to be true for it to be true. So we have A is true and B is false. B is false. So true or false, since at least one of them is true, then it'll return true over here. So yeah, this returns true. Um then we have A being false or B being true. So since at least one of them is true for this case, it's gonna return true. So false or true, it's returning true. And then for our final case, so we'll have A being false, B being false. Um, so A false, B false. So remember, or for it to be true, at least one of them has to be true. But since neither of them are true in this case, then this is just gonna ultimately return false. Uh, all right. So now, for this next column, I'm gonna be combining uh not with and. So don't focus on this. Don't focus on this. This time also remember what we got for this part. So this one is not A and B. So whatever A and B outputs, it's gonna do the opposite of that since there's a not in front. So let's say we have A being true, B being true. So remember, true and true, we determined it was true. But then because there's this not over here, it's gonna end up being false. So this column and this column, they're just gonna be complete opposites. So yeah, this is false over here. For the next case, we have A being true and B being false. Okay, so A being true and B being false. So remember, for true and false, it's going to return false since both of them are not true. But then since this part is false and then we have a not in front, it's gonna end up doing the opposite of that. So if you see over here, it becomes true. Uh, okay. For our next case, we have A being false, B being true. Remember, since both of them aren't true, it's going to be false, but then we have a not in front. So the not is going to reverse this false to become true. So this case returns true. And for our final case, all right, we have A is false and B is false. So since at least one of them, or sorry, both of them have to be true and both of them are false. So as we did before, A and B will be false. But then since we're doing not, which is the opposite, then it's going to take the reverse of that. So this will end up being true. All right. Uh, so then for our last case, uh, so don't pay attention to these ones. All right. So for our last case, we have, so it's not A or B. So whatever A or B returns, we'll do the opposite of that. Okay, so we have A is true, B is true. So uh true or true. So remember for or at least one of them has to be true for it to be true. And since both of them are true, it's going to return true. And so yeah, this is true over here. And this not in front reverses it, so it becomes false over here. So yeah, with these two columns, it's like this is going to be the opposite of this one. Um, the next case is going to be true and or false. So this returns true since at least one of them is true. Then we have this not in front. It reverses it. It's going to make it false. So this part is false over here. Um, then our next case is A being false. A being false, B being true. So since at least one of them is true, this returns true. Then we have a not in front, so it reverses it, and not true will end up being false. So this case is also false. And then for our final case, so we have A being false, B being false. So in order for this to be for or to be true, at least one of them has to be true, but both of them are false. So this will be false over here. Then we have a not in front that reverses it, so this becomes true. All right. So um so that's good for now. So if everyone could get on Eclipse, uh so we'll be going over the exact same problems that we did before. Uh so if you have your solution saved, or you can go ahead and or you can keep it and just code it below. Um but I'm gonna show you how you can, do these problems using and or, and you can make the code a lot shorter. So, so yeah, if you'd like to follow along, feel free. Um, so for this problem, squirrels get together for a party. They have cigars. A squirrel party is successful when the number of cigars is between 40 and 60 inclusive, unless it's the weekend, in which case there's no upper bound on the number of cigars. Okay, so just to go through the logic, we can split this up into two. So this is what I had before. We can split it up into two cases where it is the weekend and it's not the weekend. So if it is the weekend, then we uh we want to return whether the number of cigars is so yeah, we want to check if the number of cigars is between 60 and 40. So if you remember last time we did something like this where we checked, okay, if cigars is greater than or equal to 40, then we checked if cigars or no, this, sorry, if it's the weekend, there's no upper bound, so we just have to check this. So we can just return whether cigars is greater than or equal to 40 or not. But for this other case that we had, we did, we checked if cigars is greater than or equal to 40. Then we checked if cigars is less than or equal to 60. So we can just combine that with the and. So we can do, so if cigars greater than or equal to 40 and cigars is less than or equal to 60, then we want to return true, otherwise return false. So instead of having to, do return true or like return false, we can just return the statement that's inside of here. So we can just say we want to return whether cigars is greater than or equal to 40, and cigars is less than or equal to 60. And remember this the whole logic that I went through. So, if this statement is true and this statement is true, it'll return true. But then if this is true, that's false, it returns false, and so on. So that's kind of how this works. So that's how it'll determine if this becomes true or this becomes false. So uh so yeah, if we go ahead and run it, you'll see that it works. So a way you can make it even shorter, you can do it in one line, is you can say if it is the weekend and this number of cigars is greater than or equal to 40. So that's this first part over here. Or it is not the weekend and the number of cigars is greater than or equal to 40 and the number of cigars is so between 60 and 40. Uh then uh so yeah, if it's so this is just like squishing it all in one line. Uh, but if it is the weekend and the cigars are greater than or equal to 40, or it's not the weekend and the cigars are between 40 and 60, then it's going to return true. So, this is just how you can like compress it into, so I have like, these two cases over here and I compressed it all into one line. So if we go ahead and try this out, we'll see that, it works. And you can just, so like, using this and or and not, you can make these, God, uh, you can make it very short. So I'll go ahead. If you haven't had the chance to copy it down, I'll paste it. Um, Mohammed, you have a question?
Yes, I have a question. So I was like I wasn't here before like 29 minutes ago.
Okay, so we'll send out the recording. So if you want to rewatch the first part, then
Okay.
yeah, it's for the part that you missed.
Okay.
All right.
Yeah, which one are you doing the cigar party on?
Yeah, so we're doing the same ones, but we're trying to make it shorter, just uh using these and or statements. So I pasted the code in the chat, the one line code. Um, so yeah. All right. Now for date fashion. So with date fashion, remember, basically if uh so if you or your date have a style of 8 or more, you return true. Sorry, you return 2. If you or your date have a style of less than 2, then you return 0, and otherwise you return 1. So this one's a bit harder to do in just one line, but we can combine the logic. So we can say, so remember I had two different ifs. I had like if and then another else if that checked separately for you and uh the date's style. So I can combine that all into one line. I can say if you are greater than or equal to 8 in style, or dates greater than or equal to 8 in style, then we want to return 2. Otherwise, if you are less than or equal to 2 in style, or your date is less than or equal to 2 in style, then we return 0 for no. And then for otherwise, in all other cases, we return 1. Uh, oh, okay. Uh, okay, so I have to check this first because it prioritizes that your someone's style being less than or equal to 2. So I'll just move this up here. Um, whoa, okay. Oh yeah, and then I have to change that to 0, change that to 2. Okay. So yeah, we can make it shorter using these. Uh so yeah, with what we learned, I think this is probably the shortest we can make it. But I'll send this in the chat. All right. Then next one, squirrel play. Uh uh all right. So this one, they're squirrels. They spend most of their day playing. So they play if the temperature is between 60 and 90. But then if it's summer, they play between temperatures 60 and 100. So given the temperature and whether or not it's summer, then we can return true if the squirrels play and false if they don't play. So we can once again we can split it up into is summer and then when it's not summer. So if it is summer, the temperature has to be between 60 and 100. So if the temperature is greater than or equal to 60, Lena, you have a question.
Yes, I do. In the date fashion, it says it's wrong. That's
Um,
missing or illegal sort of expression.
make sure hang on. Is it like this? Is it inside of here and everything?
Oh, that's the problem. Because the last line, I didn't put the curved line.
Yeah, okay. Um, all right, so for this one, we can split it up into 2 cases, whether it's summer and if it's not summer. So if it is summer, then remember so last time we checked if the temperature is greater than or equal to 60. Then we checked if the temperature is less than or equal to 100, and then we return true. But uh we can make that simpler so we can return whether the temperature is greater than or equal to 60 and the temperature is less than or equal to 100. So remember, this works the same way with you know, these things over here where you have A and B. So if this and this is true, it'll return true. If one of them is false, then it's going to return false. Um, so then for the case that it's not summer, we can check if it's between 60 and 90 instead of 100, and it's the same sort of thing as here over here, as it is over here. So if we run this, we can see it works. And then if we want to make it even shorter, all into one line, we can have the two cases with an and in between. So I'll have this first case for when it is summer. So if it is summer and the temperature is greater than or equal to 60 and the temperature is less than or equal to 100, return true. Sorry, with the or in between. So the first case, if it is summer and the temperature is between 60 and 100, we want to return true. Or if it's not summer and the temperature is between 60 and 90. So if we try this, it works and we can, make it all in one line. So if when you're coding, if you want to do this, it like makes the code like really short. But if it's easier for you to go through the logic by separating it with the if and else, that's something I would recommend doing. It also makes it just easier to follow. But if you use and or and not like all in like the best way possible, you can like do these things in one line. So yeah, I just pasted the line in the chat. Uh, we will go through. All right, caught speeding. Okay, so for this one, so you get either no ticket, a small ticket, or a big ticket. Um, for yes, Mohammed.
Yes, on the squirrel play,
Mm-hmm.
I got it wrong at the short sentences. Like when you copied it, it was wrong.
Uh,
I will send it.
is it like this inside of the public Boolean and everything?
Just send it and you will tell me what is wrong.
You have an extra parentheses at the end, so you need to delete that.
At the end of this
Yeah,
sentence.
at
Okay.
the end of this line, there's an extra parentheses.
Okay, works.
All right. So as I was saying for this one, so if it's not your birthday, if you're at a speed of 60 or less, then we return no ticket. If your speed's between 61 and 80, then uh you get a small ticket. And if it's 81 or more, uh you get a big ticket. And if it's your birthday, then the speed can be 5 higher in all cases. So, yeah, if uh all right, so I can split this up into if it's your birthday or it's not your birthday. So, if it is your birthday, then uh so if your speed is 60 or less, we want to return 0. Uh, if otherwise, if the speed is less than or equal to 80. So if it's between 61 and 80, right? But then we would have already checked if it's less than or equal to 60, so we don't need to check it again. We return 1. Otherwise, we return 2. And this repeats for, sorry, I messed this up. So this should be 65. This should be 85 because this is your birthday. And then when it's not your birthday, you don't add the extra 5. So yeah, if we go ahead and run this, it works. If we want to make this shorter, we can separate it into cases by cases like when to return 0 and when to return 1 and when to return 2. So the case for when you return 0, if it is your birthday, and your speed is less than or equal to 60, or it's not your birthday and your speed is less than or equal to 65, then we want to return 0 for a small ticket. Otherwise, the second case, when you could get a 1, which is a small ticket, is, so it's similar to this. So if it is your birthday and your speed is less than or equal to 80, or if it's not your birthday, sorry, if it is your birthday, I swapped these, but if it is your birthday and your speed is less than or equal to 85, or it's not your birthday and your speed is less than or equal to 80, for either of these cases, we want to return 1. And then in any other case, we want to return 2. Uh, so yeah, this is how you can make it even shorter. If the first, if using the first sort of logic makes more sense, or it's easier, I guess, for you to like write out than this, when you're doing problems, go ahead and do it that way. This is just a way you can make it, more concise with and or. So I just pasted that in the chat. We'll go over the next one, sort of sum. All right, so for this one, it says given two integers, just return their sum. But if their sum's between 10 and 19, then you can return 20. So if sum is equal to a plus b, so we'll store sum in it as a plus b. So if the sum is between 10 uh and so if the sum's between 10 and 19, so we're saying this one, if it's greater than or equal to 10 and it's less than or equal to 19, so that means it's between 10 and 19, then we want to return 20. Otherwise we just return the sum. So yeah, this works. Let me see. Okay, so there is a way to make it shorter, but it uses something that we haven't learned yet. So I'd say for now, we'll just keep this as the shortest solution. So yeah, here's the solution. You can go ahead and copy it. All right, so this next one, alarm clock. Uh, so for this one, I can separate it into the cases when there is a vacation and there isn't a vacation. So if there is a vacation, then we want to check if it's the weekend or not. So remember, 0 is Sunday and 6 is Saturday. So we want to check if the day is is equal to Sunday or the day is equal to Saturday. So we can check if day equals 0 or day equals 6. And if it is, then we want to return off, since it says alarm clocks should be off on the weekend. Otherwise, we want to return 10 o'clock on a weekday. Then we can apply the same logic for when it is not a vacation. So if it's not a vacation and it's Saturday or Sunday, the alarm clock gets set to 10. Otherwise, it gets set to 7. So yeah, this works. Let me see. Okay, this is once again, I think there is a way to make it shorter with using something we haven't learned. Uh, if you want to know what it is, you can, so just search up, if you want to learn this on your own time, it's called ternary operator. So yeah, if you after class, feel free to, if you want to do your own research on that and learn on your own, go ahead. But for now, this is just the shortest we can do that makes sense with what we've learned. Uh, okay. All right, so last two. Um, so remember last time we did if A is equal to 6, then we also checked, oh, if uh B is equal to 6. We checked if the sum is equal to 6, then we checked if the difference is equal to 6. And then I used absolute value since we don't know if since we don't know if A is greater than B or less than B. So instead of doing all these different if statements, we can just combine it all into one. Um, so we can check if A is 6, or so return whether A is 6 or B is 6 or A plus B is 6, which so what their sum is 6. Um, or I'll put these in in parentheses just so it's easier to see. Or their difference, which we use absolute value for, is equal to 6. So yeah, these are the 4 different cases that it wants us to return true. So if A is equal to 6, or B is equal to 6, or A plus B equals 6, or their difference equals 6, then we want to return true. So yeah, you can see this works for every case. And yeah, this is the shortest way that you can do it. All right. Uh, last one here. Uh, so given a number, return true if it's in the range 1 through 10 inclusive. But if it's an outside mode, then we want to return whether it's less than or equal to 1 or greater than or equal to 1. So what this problem's saying is, uh, if it's not an outside mode, so regular mode, we want to check if it's between here. But then if we are in outside mode, then we want to check if the number is in these parts. So I can separate it into 2 cases. So when we are in outside mode, and the other case is when we're not in outside mode. So if we're in outside mode, then we want to check, oh, is n less than or equal to 1? Or we want to check if n is greater than or equal to 10. And if either of these cases are there, then we return true. Yeah. return true. So instead of doing all this, the shorter way is to check if this is true or this is true. So we can just say we want to return whether n is less than or equal to 1 or n is greater than or equal to 10. So if n is, so for either of these cases, if n is less than or equal to 1 or n is greater than or equal to 10, this will return true. Then for the inside case, so we want to check if n is, we want to check if n is between 1 and 10. So that means n has to be greater than or equal to 1 and n has to be uh less than or equal to 10. And in this case, we return, true. So instead of having to do that, we can just return so this will return true if n is between 1 and 10, and it'll return false if it's not between 1 and 10. So yeah, when we run this, we'll see that's correct. So to go ahead and shorten this even more, we can do the separate cases for if it's outside mode or it's not outside mode, all in one line. So I've separated it here. For this one, I'll do outside mode. This one I'll do when it's not outside mode. So for the first part, so if we are in outside mode, uh, and n is less than or equal to 1, or n is greater than or equal to 10, then we return true. Or if we're not in outside mode and n is greater than or equal to 1 and n is less than or equal to 10, then we also want to return true. So yeah, just to summarize, if we're in outside mode and n is like outside of 1, or it's so like if it's less than 1, or it's sorry, less than or equal to 1 or greater than or equal to 10, we want to return true. Or if we're in the case where we're not in outside mode and n is between 1 and 10, then we also want to return true. Uh, okay, so we can go ahead and delete this, and it works all with just one line. So I'll paste this in the chat. Okay, give me a second. All right, so I want everyone to go to this problem in logic 1, answer cell. I'll type it in the chat. It's called answer cell. Just look around a little, you'll find it. Um, so try to solve this problem in one line. So try to solve it in one line. First try solving it. So first try to solve this problem. Then, using kind of like what I showed you for the other 8 problems, then try to compress it down into one line. Um, so so yeah, first solve the problem. Once you've solved the problem, send me your code, um, and and let me know you solved it. And then after that, if you're able to compress it into one line, that'll be amazing. But if you're just able to solve it, that's also really good. Since you don't need to necessarily do it in one line. It's just that you know it'll show like how you can use and or and everything. Um, so yeah, this is the problem. Answer cell. Uh, try to solve it So try to solve it first and then solve it in one line. So I'll give everyone maybe 10 to 15 minutes to solve it. And then I'll go over the solution, and uh then after that we can take a quick break and continue. So yeah. And I sent the link to the problem in case you weren't able to find it.
Wait, I got it. Wait, I did it.
Okay, just send me your code and then
All right. I sent it.
all right. Yeah, that's all right. I'll just message.
I did it.
Good job. Um, everyone try for about 3 more minutes and then I'll explain. Lena, you have a question?
I did it. I'm done.
All right, good job.
Should I send it to you in the chat?
Yeah, go ahead.
Okay. Can I send my first? I send it.
All right, good job. All right, everyone. I'll go ahead and get to explaining it. So if you weren't able to do it, just don't worry. I'll go over it right now. All right, so your cell phone rings, return true if you should answer it, and normally you answer, except in the morning, you only answer if your mom is calling. In all cases, if you're asleep, you do not answer. So we can see there are several cases. So so you would answer normally, except in the morning, you only answer your mom, and if you're asleep, you don't answer. So the first case is if you're asleep. So if you're asleep, then you want to return false because you wouldn't answer. Um, Otherwise, if it is morning, so if it's um let's say the other case is if it is morning, um and your mom is calling, you want to sorry, let's say so it is morning and your mom is not calling, then you also want to return false. And in any other case, so like if it is morning and your mom's calling or it's not morning, you want to return true. So this code works. And then if we want to simplify it even more, so just as a way to uh I guess think about this, uh So we want to return. So answer the call if you're not asleep. Okay. Oop, sick. All right, sorry. Uh, okay, so you want to answer the call uh if you're not asleep. Um, and you also uh and you also so you want to make sure that it's like if you're answering in the morning, uh it, how do I explain? So like if it's morning, you only want to answer your mom. So the only other times that you do answer when is when it is not morning or uh your mom is calling. All right. So if you're not asleep and it's not morning or your mom is calling, then that's when you want to answer the phone. So if we try this, we'll go ahead and see that um it works. Uh so yeah. Just I guess a way to help think about this is like working out like different cases and then combining it together. All right. I know if some of you finished early, already had some time to relax. But we'll go ahead and uh we'll go ahead and take a quick 5-minute break for people that who are still like working. So yeah, we'll be back at around 7:16. And at that point, uh and if you could quickly open REPL.it or Eclipse, we'll be back on that. But yeah, until then, until 7:16, just go ahead and take a break. All right. We'll go ahead and resume class. So if everyone could come back from their break right now. All right. You don't need to
Question.
just yet, but um,
I have a question.
yeah.
So, are we doing the math code?
You don't need to code right now.
I mean, like, what type of code? Are we doing like the math code or the
Uh,
min job?
so wait for you don't need to um you don't need to like for this one it's just gonna be comments because we're gonna be doing like practice problems. And then we're also gonna do a bit of coding at the end. Um, but yeah, for now just I'll be going over some slides, so that's you don't need to code anything right now. Yeah. Okay. So all right, so next we'll be going over equivalent Boolean expressions. So specifically De Morgan's law. Um, so all right. Uh so the first one, basically, so we've seen A and B with the not in front of it. It's saying when you have not with a not in front of A and B, it's equal to not A or not B. And a way you could think about this, so in school, if you've, learned like distributive property, an easy way to remember this, this is not exactly the logic behind it, but you can distribute this not symbol to each of the things inside the parentheses. So you'll have not A instead of A. The and will become an or, and then the not B, sorry, and then the B will become a not B. So this is just a way to remember it. There's also this law that says not, and then in parentheses, A or B is the same as not A and not B. So if we have not the A or B, we're checking if that's equal to not A. Oh yeah, wait, I should re-explain that. So yeah, remember the trick, just to remember it is we can distribute this not symbol. So this not symbol will distribute here, here, and here. So this will be equal to not A and not B. So yeah, this is just a way to remember it. Um, I'll also go over like each specific case on the next slide. So yeah, just some examples. Uh, so for this thing, we have not, then we have, so think of this expression as A, and then we have this expression as B. So not, and then A and B in parentheses is equal to not A or not B. So yeah, these are just examples of what could A and B could be. So 2 is equal to 3, that's false. So yeah, let me just write this out. So it'll become not false since sorry, not false and true since 4 is less than 5. So we'll get not false over here, and that will become true. Then for this next, so we can, so this is equal, this side's equal to true, so we need to show this other side's equal to true. So we'll say not 2 is equal to 3, that is false. So not false. And remember, this not gets applied directly to this false versus this not over here gets applied to this whole thing. So not false or not true, since 4 is less than 5. So that's the same as saying false. Sorry, that's the same as saying true or false. And true or false will be true. And so we can see these two things are equal to each other. A similar thing with this one, we can just have a or here instead of an and then so like the and or switch, just like this case over here. And we can go through the same process and we'll find that this entire side is going to be false and this entire side is going to be false. So that shows, you know, uh, that the De Morgan's law holds true. So just to be more thorough, there are specific cases that we can go into just to prove that this law works. So for so the first case over here with A and B being true. So we have A is true, B is true. So true and true will become true. And then the opposite of true, so not true, is false. So that's why we get false in here. For this next one, so not A. So A right here, we see it's true. So not A will become false. And B over here is true. So not B will also become false. And so if we have false or false, that ends up becoming false. So that's why this is false. And we can see these two are equal to each other. All right. Next case. The next case is A is true and B is false. So we have a true here and a false here. So we have true and false. This inside part becomes false since remember for and both of them have to be true. Then we get not false. So not false ends up being true. So it's true for this side. Then for this one, so we have not A. So remember in the second case, A is true. So not A is going to be false. And then we have B is false in this second case. So then not B is going to be true. We have false or true. And remember for or, only one of them has to be true for the entire thing to be true. So this becomes true. And so then this is true, this ends up being true, and we'll see these are equal to each other. For this third case, A is false, B is true. So then false and true. Remember with and, both of them have to be true for it to become true. So since one of them is false, this inside part will be false. We have this not over here that gets applied. So not false will be, flip it to the opposite, it'll become true. Then we do this next thing with not A or not B. So A is false, so not A is going to be true, and B is true, so not B is going to be false. If we do true or false, remember, or only one of them has to be true for it to be true. So this ends up being true. That'll go down here, and we can see these are equal. And for our very last case, we have this fourth case over here where A and B are false. So we have false over here, false and false. Remember for true, both of them have to be true for it to be true. So this, uh, obviously it's going to be false since both of them are false. We apply this not that's in front, so we'll have not false, that becomes true. So this first side is true. Then for the second one, we have not A or not B. Since A is false, not A is going to be true, and since B is false, not B is going to be true. We have true or true, and for true, sorry, for or only one of them has to be true. So this ends up being true, and that goes over here, and they're equal. So we can see for all four cases of A and B, uh, these statements are equivalent. So that means not in parentheses, A and B is always going to be equal to not A or not B. Okay, so now I'll be on Eclipse. So you don't you don't technically need to copy this down. You can just get a notebook or something and write these out since this part won't be coding. But I'll just assign some, I guess, some problems using De Morgan's law that you can do. So let me just pull up the first one. Okay. So just as a reminder, uh so just as a reminder, I'll have these two laws up here. I'll go ahead and get the first problem. Okay, so this is the first problem. Simplify this as much as possible. So over here we have a not A, um, or uh, so we have a not in parentheses, we have A or, and then we have another set of parentheses here that has B and C inside of it. So I'll give everyone um maybe like 4 minutes or so to try, or like 2 to 4 minutes to try and simplify this. And when you get an answer, just send it to me in the chat and I can confirm whether or not it's correct and simplified enough. So yeah, go ahead and give us a try. You don't need Eclipse for this. You can even like do this on a notebook. Um, but we will use Eclipse like soon. But yeah.
Wait, should we give you the code or the answer?
Uh just give the answer that has like the simplified expression, basically.
Yeah.
All right. I'll give you guys like 3 more minutes. All right, so I'll go ahead and explain it now. So using De Morgan's law, basically for this first part, we can see that this is like not A or B. So yeah, this is our A, and then this entire thing is our, I guess, B for this, just for this application. So we can distribute the not, remember that's our trick. So not A, and then the or gets changed into and, then we have not B and C. All right. Then to simplify this further, so we see over here, this is kind of like the first scenario where we have not A and B, except it's just B and C. So we can, remember, distribute the not. So it'll be not A and not B or not C. So this ends up being our final answer. Um, so I didn't get to quite explain this, but basically, uh, the reason you need parentheses here is because and has a higher precedence than or. So basically what that means is like, like in PEMDAS, like multiplication comes before you do like addition or subtraction. So, and similar to that, and comes before any doing or. So you need to have parentheses around here in order to ensure that this part happens first. So yeah, this is the most simplified expression. In case you didn't get it, I'll put it in the chat. Uh, yeah. All right. Um, I'll go ahead and put in another problem. So this one is going to be a little different. This time, instead of simplifying it, you're gonna, I guess, be expanding it. But yeah, let me just get the problem really quickly. All right, so here's the next problem. So for this one, I want you to use, so A or B, it's a very simple expression, but I want you to use not and statements only to change this expression. Um, so yeah, there shouldn't be any ors in your answer. So you should be able to have an expression that only has uh only has nots and ands in it. So yeah, go ahead and try this out. This one's a bit more challenging. But yeah, I'll give you maybe 5 minutes to do this, and then I'll go ahead and explain it. Once again, send me your answer once you get it. Naga, question.
Uh, I kind of didn't understand what you said, what to do about like that thing, the question.
Okay, so this one, you want to change this so that it uses ands. So ands are like these ones over here, and nots. So the exclamation, that's the not. And you can use, so remember, these are the laws that we learned up here. So if you can try to use these laws to change this to make it have nots and ands. So yeah, that's basically what I'm asking you to do.
I got it,
All right. Once you get
I
it, just
think.
yeah. Once you get it, just send it to me.
Can you put it in the chat? The question.
Yeah, I'll put the question in the chat just so it's easy. I'll explain it in about 2 more minutes.
I got it.
All right, so I'll go ahead and go over the answer. So this one, just to just to explain it, like I guess in terms of math terms. So like with number one, right, you were distributing the knot. So you were like, putting the knot and like applying it to each of the terms inside the parentheses. So like that's kind of like, if you have like 5 times 2 plus 3 and you distribute the 5 in here and here, so it'll become 5 times 2 plus 5 times 3. Now, for this one, it's a little different where you have like 10 plus 15, but you're trying to pull out like a factor. So let's say like for this one, we're pulling out a 5. So when you pull out a factor, this will become 5 times 2 plus 3. So this is the kind of way that you would like want to think about this next problem. So for this case, like instead of pulling out a 5 like we did here, we're gonna be pulling out a knot. So we know we want a knot here. Um, so in order to make the stuff in the parentheses, so we pulled out a knot. So now we want to make the stuff that's inside the parentheses the opposite of what was here. So uh so we pulled out a knot from the A, so that means the A will be uh flipped, so or like it'll change into the opposite Boolean, so it'll become from A to not A. For this or, remember we pulled out the not, so from or it'll become and then for the B we pulled out not, so it'll become not B from A. And so this is the answer. And if we want to confirm this, we can even like redistribute this not again just to show that it works. So if we put this not over here, not A, that'll cancel out. That becomes A. If we have not with the and, it'll become or. And then if we have not B, so the knots will get canceled, it'll become B. So we'll see if we redistribute it, it'll become the same thing that we started with. So yeah, that is our answer for that one. Uh, I'll paste this in the chat. Okay. And then I believe I have one more problem. So just hang tight. Um, yeah. Okay, so for this final problem, I want you to simplify as much as possible. So this is, remember, this is like distributing the knot. This is not pulling out a knot. So yeah, like, expanding, like if you have like 5 times 2 plus 3, you're multiplying the 5 to each of the terms. So that's the kind of approach that you want for this question. So I'll go ahead and paste the question in the chat. So yeah, here's the question. And so uh I'll give you 5 minutes for this one, and then I'll go ahead and explain it. Naga, you have a question?
Do we need to like what do we need to do again?
You need to simplify it using De Morgan's law. Actually, yeah, let me paste the De Morgan's laws down here. So here are the 2 laws that you can use.
So we need to simplify it as much as we can.
Yeah, simplify it as much as you can with De Morgan's law. And this is the statement down here. I also put it in the chat. All right, so 4 more minutes, then yeah. All right, I'll go ahead and explain this one. So, uh, so in order to simplify this one, we can distribute this not over here to each of these terms. So we'll get not A or not B. So first we're using this one over here, the second law, and we can think of each of these big chunks as just one term. So if it helps to think about it, you can just think about this as E, think about this as F. So yeah, we'll have not and this big thing over here. Then the or changes into an and. Then we'll have not of this next big chunk over here. So C or D. Then we can simplify each one further. So this not A or not B, we can distribute this not to each of these things. So it'll be not A, the or will change into an and then this not B will change into a B. Uh, then to do the second part, we can use this second law here once again. So we'll have not C or D, that changes into not C and not D. So this not is getting distributed. So it'll be not C, then the or will change to and the D will change into not D. So over here is our final answer. It's not A and B and not C and not D. All right. Um, so uh all right, so there's one more thing to go over. Uh so let me oop, uh all right, let me paste this solution in the chat. Uh so yeah, these are the steps with the not being distributed. And I pasted the solution. Oh wait, that's just a problem. Um, all right, this one's the solution. Lena, you have a question.
Yeah.
Okay.
My question is, can you copy all because I don't write them all.
Okay. I can just copy this whole thing. Um, all right. So the last topic of chapter 3 that we need to go over is comparing objects. So so um so remember when we compared objects before we used so like with integers, doubles and stuff, we use this double equals operator. And so what this does is it checks if two variables reference the same object. Um, so it's a little different than the dot equals that we used before. So hang on. Um, so like with this over here, we have x equals new string hello. So what this will do if we just go line by line, it has this variable x. It will point to this new string that we created, hello. Then if we set y equal to x, Mohammed, you have a question?
Yes, I have a question. Did you write the solution and stuff?
Yeah, all of the solutions are there.
Is it A and then B and then
Yeah. Everything's in the thing I pasted in the chat.
Okay.
All right. So when we do string y equals x, what it'll do is it'll create this pointer over here. So now y will point to the same thing as hello. So when we check if x is equal to y, this will return true since they both point to the same thing. Um, so yeah, but then this is the second scenario, which is a little more, uh, I guess, a little more weird. But when we do this scenario, we have x over here, right? So when you create it, it'll point to its own hello. And then when you have y over here, instead of pointing to that hello, you said new string hello. So the y will point to its own hello. So what happens is then when you do this, it's going to end up it's going to end up printing out false, even though like they're both have hello in here, it still ends up returning false because they don't point to the same thing in like the variable memory. So it's a bit weird, but just know that if you want to check if the text is equal, then you use x dot equals y. And so this will end up being true since they both have hello in there. Um, so uh so yeah, just if you do dot equals, it'll check the text. But then with strings, if you do this double equal sign, it'll check if it points to the same thing. So it's gonna be so yeah, you might get unexpected results when you use double equals. So just the main thing to take away is make sure to use dot equals for strings. I can go ahead and uh paste this just to show you. So
Could you copy it?
yeah, I'll copy it. So yeah, just to show you, we created X, it points to its hello. We created Y, it points to a different hello. So when we run this and we check this over here, it'll be false, but then this one over here will be true. So yeah, so you can see it's weird, right? It prints out false even though they're both hello. So yeah, just if you want to check the text, make sure to do dot equals because when you use this double equals over here, it's going to check what it points to, which is like with the diagram that I showed you. Um, all right, so that's it for chapter 3. I will paste this new code in the chat. Hang on, let me add some comments here. So false, true. All right, I've pasted the code in the chat. Um, so yeah, so that'll be it for chapter 3. So tomorrow you'll go over chapter 4, which will be on loops, and different sorts of iteration. So you'll have a different instructor starting tomorrow. And so he'll go over chapters 4 and 5. So yeah, that's it for class today. And yeah, tomorrow class will be at 6 o'clock with a different instructor. So yeah, feel free to leave. And yeah, that'll be it for today.
Bye. Thank you.
Bye. No problem. Um, no problem. Bye. Mohammed, you have a question?
I think you.